Lesson 4.3 is about modeling with quadratic functions. So we're going to eventually look at some real life data and see how you can write an equation to it and then use that equation to predict future values. For example, we could write an equation to model the path of this basketball, which we will do at the end of the lesson. In order to do that, we are using our standard form equation. In the standard form equation, we have to figure out A, B, and C. Since we are trying to find three variables, we will need three equations. So in order to write the three equations, we're going to need 3 points, and then we'll solve a system of equations. So here's our example. This is quite involved, so you may need to come back and watch it several times to figure it out. Hit pause as much as you need to, but we're going to start with our standard form equation, y equals ax squared plus bx plus c. So we have our first point here, 1, negative 2, where 1 is x and negative 2 is y. So we plug that into the standard form equation, giving us negative 2 equals a times 1 squared plus b times 1 plus c. If we simplify this equation, we get negative 2 equals 1 squared is 1, a times 1 is a, b times 1 is b, and c. Then we will take our next point, 2, negative 4, and plug in for x and y. So we get negative 4 equals a times 2 squared plus b times 2 plus c. This gives us negative 4 equals 2 squared is 4, so that's 4a, plus 2b plus c. And then we will take our third point, where 3 is x, negative 4 is y. So we have negative 4 equals a times 3 squared plus b times 3 plus c. This will give us negative 4 equals 9a plus 3b plus c. Next, what we need to do is solve this system of equation by eliminating variables one at a time. So if we multiply this second equation by a negative 1, that will give us positive 4 equals negative 4a minus 2b minus c. Now we can combine equations, and when we combine them, the c's will add up to 0. So if I add these first two equations, negative 2 plus 4 is 2. 1a minus 4a would be negative 3a. 1b minus 2b would be negative b. And 1c minus c would be no more c's. So I have eliminated c's one time. Now I'm going to combine the second and the third equation. So 4 and negative 4 is 0. Negative 4a and 9a is 5a. Negative 2b plus 3b is b. So this worked out nicely because now with our two equations that remain with our two variables, if we add them together, we can eliminate the b variable. So adding this up, we get 2 equals 2a and b equals 0. Dividing by 2, we get a equals 1. Now we're going to take this a value and we're going to plug it back in. We could plug it into either one of these two equations, but I'm going to plug it into the second one and calculate for b. So I have 0 equals 5 times 1 plus b. So 0 equals 5 plus b. And subtracting 5, we get b equals negative 5. Now I can take the a and the b, and I can plug them both into any one of these three equations that we had calculated. So I'm going to plug them both into the red equation. So the 1 goes in here, the b goes in here, or the negative 5 goes in here. So we get negative 2 equals 1 minus 5 plus c. 1 minus 5 is negative 4. Adding 4 to each side, we get c equals 2. So now we have A, B, and C. So we can write our equation in standard form. Y equals 1 times x squared is just x squared. Negative 5 times x is negative 5x. And C is 2. So there is our equation. Okay. Here's a problem for you to try. So hit pause while you try it, and when you're done, hit play, and we will look at an example of a basketball player. Okay, for our basketball player, we have a player here who shoots the ball, and it goes through these 3 points. The defender did not touch the ball, so we want to know if the ball continues on its path, will it go through the hoop? So we're going to first write an equation for the path of the ball, and then we will check and see if it goes through the point 12, 10. So first thing we'll do is write our 3 equations. You hit pause while you write the equations, and when you have them written, hit play. Okay, here are the 3 equations. Now from these 3 equations, we will multiply the middle equation by -1, and then combine the top 2 equations to eliminate C, and the bottom 2 equations to eliminate C. Hit play when you're ready. Okay, now we have eliminated the C variable. Next, we would like to eliminate the B variable, so I'm going to multiply the top equation by +3, giving us -6b that will cancel with the +6b in the second equation. Hit play when you're ready. Now I have eliminated the b variable, so dividing both sides by 48 gives us a. And since it would be easier to work with decimals, I'm going to go ahead and change this into a decimal, and I get -0.125. Then we're going to take this a variable and plug it back into this top equation for a and calculate for b. So hit pause and hit play when you're done. Okay, and solving for b, we get 1.75. So now we can substitute a and b into the top equation up here and calculate for c. Hit pause while you work on it, hit play when you're ready. So we get c equals 7. So now our equation for the path of the basketball is y equals -0.125 x squared plus our b value is 1.75 and our c value, oops, this is an x, 1.75x plus 7. So now we still want to know, does the ball go through the hoop? Since the hoop is located at the point 12, 10, we're going to put 12 in for x and see if the equation equals 10. So we're checking to see, does 10 equal what we get when we plug 12 in? So calculating, we have -0.125 times 144 plus 1.75 times 12 is 21 plus 7. -0.125 times 44 is -18. Add 21 to that, you get 3. Plus 7, you get 10. So yes, it does equal. And since the ball will pass through the point 12, 10, then we know the ball will go through the hoop. So the answer is yes, the player scores. That's the end of this lesson.